So for today's lesson, we are going to do with linear and quadratic systems, and we're going to deal with them by graphing. This actually should take you back to last year. So the idea of having linear quadratics means you've got a line and you have a parabola. So the solution of a linear quadratic system consists of the intersections of the graph of a line and that of a parabola. If you think about the way that a linear and a parabola can intersect, you might have a parabola like this and a line down here, which means a linear and a quadratic may consist of 0 points, no solutions. You might also have one that you've got a linear like this, and maybe your line is tangent to that parabola, which means it just touches it in 1 point. Or maybe you have your parabola and then your line that kind of slices through it, and it slices through it in 2 points. So either 0, 1, or 2 would be your solutions, and we'd have specific ordered pairs. But for us, we're only going to worry about those that have 2 points as their solution. When you solve a linear and quadratic pair graphically, you want to make sure that you draw the graphs of both equations on the same coordinate plane. When you're graphing the quadratic, you always want to create a table of values that's centered around the vertex. If you remember anything about this from last year, that in order to find the vertex, you're going to be able to use the axis of symmetry equation to find the x-coordinate. So the x-coordinate would always be negative b over 2a. Remember, you're dealing with a quadratic in standard form, and you're given the quadratic of ax squared plus bx plus c. So when you're trying to find the x-coordinate of the vertex, you're dealing with the thing that's attached to the x and the thing that's attached to the x squared. When you want to find the y-coordinate, you're just going to plug in that x value, do the math, and solve for y. So basically your vertex then is going to be ordered pair negative b over 2a comma y. Once you end up graphing both the line and the parabola, you're going to find the common solutions by reading the points of intersections of the two graphs. You probably want to check your solutions on the calculator because while your line's probably going to be perfectly straight, your parabola might be off a little bit, especially if you're only going to be using 5 points to graph your parabola. So you can always use these steps on the calculator. Second trace intersect, enter cubed, which means you're doing enter 3 times. Remember, you have to do it twice because we're looking for 2 solutions. Once you find your 2 solutions, you write them both as ordered pairs. So your solutions of the linear quadratic are going to be 2 xy coordinates, and 2 different ones. So we'll do the first one algebraically, but the second one we're just going to do in the calculator, because again on the regions, I don't think it matters how you do it, but let's kind of bring some algebra back, and then let's see what else you remember. I'm going to go for the line first. The line's going to be the easiest thing to draw because there's no issues here. So we've got this line right here, y equals negative x plus 3. I'm hoping that you remember when you graph a line, you're going to begin at the y-intercept, which should be positive 3. Your slope is negative 1 over 1, down 1 over 1, and then you're going to graph your line. So here is our line right there. We've got this, and here's our y equals negative x plus 3. The parabola is a little bit different. If we deal with the parabola using the formula for the x-coordinate, using the axis of symmetry, and then we plug in for y, it's going to look like this. The x-coordinate is negative b over twice a, which means negative b happens to be, in this case, negative 2 over twice a happens to be a 1. When the math gets done here, you're going to get 2 over 2, or the x-coordinate being 1. So right now the x-coordinate of the vertex happens to be 1. We've got to find the y-coordinate. The only way to find the y-coordinate is to go through the problem, and everywhere we see an x-coordinate, we need to plug in that value of 1. When we do the math here, we get 1 squared minus 2 plus 1. This comes out to be -1 plus 1, or y comes out to be 0. All of this basically just says to you that if we had a table of values centered around our vertex, the vertex is going to be 1, 0. That's your vertex. Then what we did in algebra is we said, okay, well, we need to have 5 points to graph the parabola. So on a number line, if we've got 1 in the middle, to the right of 1, you'd find the values of 2, then 3. To the left of 1, you'd find the values of 0, -1. We've got to find the corresponding y coordinates for these x values. So then you go back to your parabola and you start plugging in different values for the x coordinates. So if I'm going to use 0 and I'm going to plug it into the original equation, in other words, let me erase this up here. If I'm going to use 0 and plug that in for the x's into my quadratic, 0 squared minus 2 times 0 plus 1, you're going to get 1. And whatever 0 is for the y coordinate, 2's x coordinate has the same y value. If we now go in and we plug the next round, and I'd rather plug in the positive over the negative, if I plug in 3 for my x's, 3 squared is 9, 2 times 3 is 6, 9 minus 6 is 3, 3 plus 1 is 4. Now I have those corresponding y values. So we're going to plot the parabola. The parabola is going to be the vertex at 1, 0. Use a different color pen. So the parabola, we're going to go over 1. We're going to stay at 0. We're going to do -1, 1. We're going to do 0, 1. We're going to do, something is not right here. Hold on. What am I doing? So let's start from here. -1, 4. That's why. So -1, 4. Here we go. 0, 1. 1, 0, 2, 1, and 3, 4. And there's your parabola. Well, there are two places where the parabola and the line intersect. It looks to me like that's happening here and here. I think I can probably guess the ordered pairs, but I'm going to take a look at the calculator as well. My guess is the ordered pair is that -1, 4, which was that one. And then I would also have to guess that the other ordered pair is going to be 2, 1. But I'm going to check this in the calculator. Here we go. Get your calculator. You can go to y, whoopsie, I'm still in the highlighter mode. Go to y equals, type in that quadratic, x squared minus 2x plus 1. I'm going to go into y2. I'm going to type in the line, -x plus 3. We're going to take a look at the graphs. Pretty sure that's what ours look like. Yep, looks good. And then we can find these solutions one of two ways. One of the ways we can find it is to be able to find out where the y values match up, if the x values, whatever the x values might be. So one way would be is, let me take a look at my table of values. We talked about -1, 4 being a answer, and it turns out that -1, 4 is, because look, when x is -1, both y values are 4. And the other one that looked like was 2 when x was 2, and that's right because both y values are 1. So those happen to be the two solutions. The other way to do it, the second trace intersect way, is exactly what that is. We go back to the graph, we go to second trace, so it's second calculate. We're going to go to choice 5 because that's the point of intersection. We're going to hit enter, and then we're going to hit enter again to answer first curve. We'll hit enter to answer second curve, and do we want it to guess? And we sure do. And then again, there's our first choice, -1, 4. We have to do that again to get the point that's over on the other side. So here's the -1, 4 point. When we do it again, second trace choice 5, before you hit enter, 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 you need to use your right arrow pad and move it over to the other point. Get it away from that first point. Now hit enter once, twice, 3 times. And then there we go. We've got our 2, 1. Okay? So when we go back to our worksheet and we have our solutions happen to be the two ordered pairs, -1, 4 and 2, 1. I'm hoping this looks familiar from last year. Okay. On the next one, we're doing it all in the calculator. It just makes our life easy and nobody says that we can't. First thing you have to do though is to be able to graph the line. You've got to get it into y equals on your own. So I'm going to add x to both sides and get y equals x minus 2. This is easy to graph. Begin at -2, up 1 over 1. Going to take my line, going to connect the dots. You should label your line and your parabola, even though we know one's a line and one's a parabola. So we've got this guy being here, y equals x minus 2. For the quadratic, I'm just going to go right to the calculator, and I'm going to have it find the table of values and everything for me. So if I go to the calculator and I erase what's on here and I type in this new one, let's go to y equals, let's clear out and clear out. Okay, let's make this easier. So y1, quadratic, just the quadratic, x squared minus 6x plus 4. Let's graph it. The vertex looks somewhere like it's maybe over 4 and maybe down 4 or something along those lines. So we're going to use a table of values to actually find that. So I'm going to go to the table of values. I'm thinking that we're over 4 down 5. Am I right? Close. It's actually over 3 down 5. And the reason why we know that that's the vertex is because look around the y value of -5. On either side of it, it's -4. And then one more on either side, it's -1. So we actually now can plot these particular points. I'm going to graph them off the table of values. And so we're going to take, you can take all 7 of them. I'm going to take the actual middle 5. So I'm going to go back to my chart or go back to my notes. And I'm going to say, okay, well, here's my XY chart. I'm going to have 1, -1. I'm going in order. 2, -4. 3, -5. 4, -4. And 5, -1. These are the points I'm going to plot. 1, -1. That's not 1, -1. Try that again. 1, there we go. 1, -1. 2, 1, 2, 3, 4, 2, -4, 3, -5, 4, -4, 5, -1. There's my parabola. Not so sure where I intersect. Go back to my calculator. I'm going to go into y equals, type in the line, y equals, y2. This was x minus 2. Try that again, x minus 2. Graph it. Graph it. And second trace intersect. Actually, I might even go to the table of values. It might be even easier. Go to the table of values. Let's see. I've got y values the same here. So 1, -1. And I've got y values the same here. 6, 4. So those are the actual solutions. And then if we go back, and that makes sense, right? Because 1, -1 is the guy that's right here. And then 6, 4 is the guy that's right here. So that looks great. So come back, and then our solutions, we have it at 1, -1, and 6, 4. That's it. That is the end of this particular unit. Okay, so we'll have a quiz in a couple of days, but we're done. All right, so you get the homework, and all is well. Have a good day.